Hello, Mr. Burst. I'm live from my closet. I'm gonna explain to you about the four forces of nature. I'm doing a video because I didn't want to do a presentation because those take too long. Videos are quick, so also because I like doing videos. Anyway, the four forces of nature, fundamental forces of nature. The first one is electromagnetic. How my computer? Electromagnetic force. The definition is it basically includes like electric force and magnetic force all in one. It's like when we learned about it in the coils, when the electricity goes through the wire, that's electric, and then when the particles are moving, that makes a magnetic field, and so it's like electromagnetic force. And in the real world, like this is what keeps me, like a real world example is what's keeping me on this beanbag and not sinking through to the middle of the solar system because of gravity is pulling me down. But I'm not going through the beanbag because my like back particles are pushing away from the beanbag particles, and so because of like the magnetic field, I think, so I'm like sitting here and I'm not falling through forever. The next one, oh no. Something interesting is I think it's cool that, the electromagnetic force can just turn a wire into a magnet. Like, that's kind of weird because the wire still looks the same, but it's completely different. It's a magnet. So I thought that was kind of cool. The next one is the weak force. The weak force is, like, creates particle decay, can make, like, a particle turn into a different particle. I'm pretty sure this is how it works, but, like, if they get too close together, then the bosons, I think, no, maybe the quarks switch, and like if that happened to a neutron, then the quarks would like fall out and it would turn into a proton, and then it would change the element because the proton depends on the element. You kind of explain that in your video, but like I think that's what the weak force is. It just it changes an element if they get too close to each other. In the real world, this is what makes nuclear fission, which is what makes the sun work, and the sun heats us up. So that's in the real world. An interesting thing is, I think it's crazy that like bosons, I think that's what it's called. Bosons exist because they're a part of the neutrons and protons. I think it's crazy that they exist because I thought that neutrons and protons were the only like little thing that exists, but there's also those. And the next one is the strong force. This one is the force that keeps the subatomic particles in the nucleus and not lets them escape. It keeps like the protons in the nucleus because protons are the same charge, so they usually would repel like a magnet, two same sides of a magnet, but the strong force keeps them all together and like keeps it contained. And it's really strong because it has to like be stronger than a magnetic force, I think. In the real world, the strong force. Oh yeah. This is what makes like the atoms of like me stay together. No. This is what the nucleus and the atoms of me makes it stay together. So without this, I would just like explode, I think, because all the nucleuses would break apart and that would be really bad. And an interesting thing is, it's not really an interesting thing, but I wonder what would happen if there was no strong force. Wait, that's what this one is, right? Yeah, if there was no strong force, because, like, what would happen if there was no strong force? Would it just, the whole universe be like slime? Because none of the nucleuses could stay together, so what would happen? Would there be no nucleuses, no atoms? I don't know. And the last one is the easiest to understand, I think, is gravitational force, and that's the attraction between two objects with mass or energy. The most obvious real world example is the solar system, like all the planets keep together. It keeps like our moon to us, makes tides and stuff. But but another real world example is like if you're running super fast and you drop your wig, you're wearing a wig, you're running super fast and you drop your wig. The reason why your wig goes to the ground is because, by the way, I don't wear a wig, I just thought of that. You drop your wig, the reason why your wig drops to the ground is because gravity is pulling it to the ground, to the big middle of the earth, because the earth has a great mass. So, but if you throw your wig up into the air, then when it's going up in the air, it's like defying gravity because it's going up instead of down, because gravity is really weak. And that's like my interesting thing is, you kind of said this in your little video notes thing, but it like, how is gravity the weakest one? Because like the strong force, it only has to keep like tiny little particles together in a nucleus, but gravity has to keep a whole entire solar system together, and that has so much more weight to it. So how is it the weakest one? I don't really know, but I think I kind of get all of them. I'm a little bit confused still on the weak force, but I think I'll get it. But those are the 4 fundamental forces of nature, and thank you. Text and turn it off.